So LeetCode 55, jump game. For this problem, you're given an array of integers and you are starting at the first index and you want to return true if you are able to get to the last index. And the constraints are that if you start at 0, you can move to the right by nums of 0 steps. So this is the maximum length of a jump that you can make in the array. So for example, initially we start here, we can jump up to right here. And then, for example, if we start at 3, then we can jump up to right here, meaning the last index of the array, and so we can return true. So to solve this problem, you can basically just keep track of the maximum index that you can reach by doing some jumps. So that would be initialized with 0, because you're positioned at the first index of the array, which is 0. And so then at every step, so you move forward up to that bound, which initially is just the first element, and you always update it with the maximum between the current bound and the current position plus the maximum jump that you can make from the current position. So for example, here, the current bound is 0, and we can jump up to the index 2. So we update our bound, and now this is the window. These are the elements that we can reach, right? And so now we can see that here we have a 3, meaning that if we start from here, I can now update my bound to be up to the last index of the array. And so there I can immediately return true. Okay, so we're going to implement this idea. So we're going to have to keep track of the current element that we are visiting. We're just going to call that I. And then we're going to have to keep track of the maximum right index that we can reach by doing some jumps. And I call that max index reachable. Okay, so now what you're going to want to do is you're going to have a loop, and you're going to do this loop while your index is less or equal than the maximum index that you can reach. So for example, if I goes above the maximum index that you can reach, you want to stop because you can't reach that index, that position. And so yeah, you need to stop and basically return false essentially. So what we do inside of this loop is we update our maximum index that is reachable by saying if we have a greater possible index, we update this one. So we use the mathMax function for that. And the new index that you can reach is your current position plus the maximum length of the jump that you can take at your current position. So for example, if the bound initially is 0 and we visit the first cell, we can update that with 2 because we do 0 plus 2 and we update with a mathMax. Okay, so now what you want to do after doing this is incrementing I, or else you're always going to stay on the same cell and you're going to have an infinite loop. And then you want to also check if you have now got a maximum index that is reachable that is greater or equal to the last index in the nums array. And if so, then you can straight up return true, right? So if your maximum index that is reachable by doing some jumps is greater or equal than the last index of the nums array, then you can return true. But if we never end up in this line, in line 11, meaning that we never have some kind of jump that leads us to having a maximum index reachable that is greater or equal to the last index of the numbers, then we're going to have to return false, right? Okay, so that's it. I'm going to submit the solution to show that it works. And the time complexity is O of n, because we just go through all of the elements one by one. And the space complexity is O of 1, because we don't have any weird data structures or anything like that. So that's it for me. Thank you for watching, and bye.